This is about solving a system of linear equations in three variables. Alright, so here's a linear equation in three variables, 1, 2, and 3, right? X, Y, and Z. And to solve a system of linear equations in three variables, you must have three equations. Alright, basically think of three dimensions, so you're thinking these are planes now, and it's where these three planes intersect. Okay, they intersect at one common point then. Show that this is a solution to the system. Basically, if we want to know if x is -1, y is -3, and 2 is a solution to this system, if we put these values in here, they must be all true in all three cases. So you can see that -1 is in place for all the x's, -3 for all the y's, and 2 for the z's, and it is true for each one of these cases. This is the point in the three dimensions world where all three planes intersect. Okay? Now how do we find that solution? Well, here's a combination of elimination and substitutions to do that. So first step, reduce the system to just two variables. So check the whole system out and see which is the easiest variable to eliminate, and eliminate that variable and reduce the whole system to two variables. Second thing, solve the system of the two equations. So then you'll have two equations with two variables, so solve each system. Back substitute to get the other variable, and 4, check the variables step 3 and step 2 to get the remaining third variable through substitution, and then check solution. Alright, let's do one, and you can see how that all plays out. First example. We're supposed to solve all these, the system of linear equations in three variables. I've color-coded it to hopefully help. So what we're going to do is we look through here and we choose to eliminate x, y, or z. Okay? Well, I choose to eliminate z. Okay? So I'm going to focus on this column there, eliminating z. I'd like to choose these two equations first and eliminate z. So multiply the top one by 5, the bottom one by 7. I will get, right, 35 and -35. When I add them together, now I have this equation here and there's no z. Now I've used this one and this one, but I never touched this one, right? So now I've got to use this one with one of the other two equations and eliminate z also. So you'll see I'll have this green equation with only x and y. Now if I use this one and eliminate z with another one of these, I'll only have x and y. So let's choose this equation and this equation and eliminate the z. So here's the original second equation, the blue one. Eliminate z, multiply by -3 gives me a +15, multiplied by 5 gives me a -15, and add those two together. So now here's my second equation. So remember, I took first and second equations, and we got this green one when I eliminated z. Then I took second and third equations and eliminated z and got this one. So going back up, first of all, I did this one, first equation with second equation, eliminated z. Then I took this equation with this equation, and eliminated z. Now I've got these two new green equations now. They'll only have x's and y's in them, so I put them together like this, and now we're going to eliminate either an x or a y. Let's choose to eliminate the y. So basically, because one's 29y and 29y, if I multiply maybe the top one by -1, now I can add them down, I eliminate the y's, and I just get x equals -1. Alright, so now I've solved for x. Now I start back substituting. I can put this x equal to -1 in here or here. It doesn't matter, and I'll get a y variable. So I choose to put it in to 16x plus 29y equals -74. Put the -1 in right there. Work it out. And now y is -2. Now I have x and y. Now I go back and put them into any one of the three equations where I had x, y, and z at the top. Here's x, y, and z. And that's just going all the way back to the beginning here. That's just the first equation, right? With the 13, 2x plus 3y plus 7z equals 13. I'm just putting in the x, the y that I found, into that one, and now I solve it down for z. Z is 3. Now -1, -2, and 3 were the three values, and that's the point where these planes intersect. -1, -2, -3. -1, -2, and 3 works in each one of these, and you can put that in and it will make them all work. It makes the top one to 13, the second one to -22, and the third one to -28. Let's look at another example here. Let's solve this system. I'll call this one 1, 2, 3. All right, let's take equations 1 and 2. I'm looking through all of them, and it looks pretty easy to eliminate the y's. Look at these guys. So let's just take equations 1 and 2 and eliminate the y. So here we go, kind of stay organized. 4x plus y minus z equals 8. X minus y plus 2z equals 3. And to eliminate the y's, I can just add them together. So here I get 5x, 0, plus z equals 11. All right, there's my new equation. Now let's get another equation with no y. So they're opposites, so let's just eliminate y. Let's use 1 and 3 now. So I used 1 and 2, but I got to incorporate 3, and they're easy because they're opposites. So I rewrite 1, 4x plus y minus z equals 8. And then 3, 3x minus y plus z equals 6. Go ahead and add those down. I get 7x, 0. Oh, look, even the z's go away. That's kind of nice. And then 8 and 6, 14. All right, then I have these two equations, and I just basically you just need to solve for x here and put it in there to get z, right? Because if I use elimination, I could eliminate the x's, and I'd just get z. But also substitution works too, so you can use elimination or substitution. In this case, since there is no z here, why don't I just add them together? So, I mean, substitute this one in there. So divide both sides here by 7. X is equal to 2. So I did find x equal to 2 a little differently. Now put it in here, because you have to use these two together. More room. So 5 times 2 plus z equals 11. 10 plus z equals 11. That means z must be 1. Z is 1. X is 2. And to go back and get y, we just go back up into here and plug it into one of these guys. So let's put it here. X is 2. 4 times 2 plus y unknown minus 1 for z equals 8. 8 plus y minus 1 equals 8. 7 plus y equals 8. Y equals to 1. So it looks like 2, 1, and 1 is my solution. And you can check that in all three of them. Now this worked out slightly different in the fact that I didn't have to use elimination on this equation and this equation, but you're either to use elimination or substitution depending on how it comes out. And I could use substitution even if there was a z here. I could have just solved for x and substituted in there, or elimination. This just didn't have a z, so I didn't need to use it. Let's look at one more example. Here it's missing some of the letters, right? But it still works the same way. Let's look at the x's, the z's, x and y, y and z, and try to eliminate one and work together to get the rest of them. So I would start maybe by eliminating the y's from, say, 2 and 3. So let's do that. 5x plus y equals to 0, and the y minus 3z equals to 0. So that's pretty easy because they're opposites, or they're ones in front of them. I just got to make them opposite. So I'll multiply everything by a -1 up on top and add down. Okay, so that gives me, I'll write it above, -5x minus y equals 0, right? 0 times -1. Now I'm going to take the red and this black and add them together. So -5x, so this is no longer here. Negative y and positive y is 0, minus 3z equals 0. Alright, I use these two. Now I got to use this one. But this one doesn't even have a y, so I can just write it like this. Which is just a system of two variables now, right? See, x's and z's. So if I took this and eliminated the y, then I just have x and z. Now I eliminate one of these two. How about multiplying the bottom one by 5? So I'll multiply this bottom one by 5 and add down. 5, 25. And 5 times 0 is 0. Add down. 22z equals 0. Divide both sides by 22. Z is 0. Alright, now I just got to go find x. Well, if z is 0, why don't we just go back to right here? Look at this. Z is 0. What's y? Y is 0. Okay. Alright, now I have y is 0 and z is 0. Let's go back to, let's say, this one. If y is 0, 5 times x is 0, x must be 0, right? So they're all 3 0, 0, 0, 0. Works in all of them. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0, or 0 minus 0 is 0. So hope that helps a little bit. Now the procedure again, reduce the system to just two variables, and that's what I did in each of those cases. Then just solve the remaining two equations, because you have an equation with just two variables, another equation with two variables, put them together and solve, and then just start substituting it back up to get the other ones. Hope that helps. Re-watch the beginning part of the video with the equations already in there if you'd like to see it without writing it through, and you can kind of look at the values that are there.